Now, I want to find the terminal point for 5 pi over 4 radians. So first thing you want to do is where is 5 pi over 4 radians? And what you'll catch on to is 5 pi over 4 radians, well, that's 1 pi and a fourth. So what you should notice is that's what we're looking for. So the terminal point is right here. So all you do is you go, okay, that point is right here, so I'm writing that coordinate right there. I'm writing the coordinate at the terminal point of 5 pi over 4. So what is the coordinate? It is negative square root 2 over 2, comma, negative square root 2 over 2. That is the terminal point at that spot. So let's try 315. 315. So let's find 315. Well, 315 is right there. All right, so let's draw that. 315 is right there. We're wrapping around. So I want this coordinate right there. So what is that coordinate? What is this coordinate? It's right there. So I'm writing the square root of 2 over 2, comma, negative square root 2 over 2. That is the coordinate of that dot. All right, for this one, I have to do a negative pi over 3. So if I go pi over 3, isn't pi over 3 right here? So if I want negative pi over 3, don't you mirror it and go down that far, so isn't it right there? So negative pi over 3 is really right there, going negative. So there's the coordinate. And what is that coordinate? Well, that coordinate is 1/2 over and down negative square root 3 over 2. Next, negative 120. 120 is right here. Negative means I go under to that, so isn't it right there? So 120 will be right there. Negative. Coordinate is right there. So what is that coordinate? Well, the coordinate is right here, so we just write that coordinate right there, which means I go over negative 1/2, and I go down negative square root 3 over 2. That would be my coordinate for that dot. Okay, so for 3 pi radians, 3 pi radians is a little bit trickier because you start here. 3 pi means I go around once, but don't you keep going? Another pi. Isn't that 1? Isn't it 3, 2 plus 1 more pi? So really, I end right there, so my coordinate is right there. And if we look at our unit circle, that coordinate is negative 1, 0. All right, next one, 720 degrees. Oh boy, 720. Well, if I subtract 360, don't you get another 360? So for what that means is I go around 360, and then I go around another 360. It's 2 360s. Twice around, there's 720. And what is that coordinate? 1, 0. It's right there. It's 1, 0. Okay, negative 5 pi over 2. So negative 5 pi over 2, so if I start here, well, 5 pi over 2, isn't that negative 2.5? So wouldn't that mean I'm going to go one time around, that's 2 pi, and a half pi, because 5 divided by 2 is 2.5, so I got another half pi. So isn't that half pi right there? So I went one time around and a half extra more. That coordinate is right here. So it's 0, negative 1. All right, next one, I'm going to do negative 450. Negative 450 is over 360, so I go around 360. Then once I go around 360, how much more do I have left? Well, if I add 360 to negative 450, I'll have 90 left over. So 90 is another right to there. So there is my coordinate. It's the same as the previous problem, 0, negative 1. Now, be careful on these ones that go over 360 or over 2 pi. You have to find coterminal angles. That's why coterminal angles are important, because when you have something bigger than what's on the normal unit circle, you have to think of multiple revolutions. So if you add, subtract 2 pi, or add and subtract 360, that makes these a little bit harder. Good luck.